Okay guys, here is our second interval video for our interval. We're looking at the mean of 1 minus the mean of 2, and we're going to do some confidence intervals. Okay, so first thing, of course, is all our conditions must be met. 4 conditions, 4 things, same 4 things that we've been talking about. Feels like forever. I'm not going to write them down. Okay, so our confidence interval is x bar 1 minus x bar 2, parentheses, plus or minus our t statistic, s1 squared over n1 plus s2 squared over n2, and that is in our square root. Okay, and then our degrees of freedom, again, we can use technology, which is that really long formula which we talked about before, and I'm not going to write it down again, but it's in the previous one. Or we could use n1 minus 1, n2 minus 1, and we're going to choose the smaller of the two. Okay, so if they're both the same, then you're okay. It doesn't matter which one you choose, you're going to have the same thing. If obviously the one's smaller, that's the degrees of freedom you're going to use in your chart. Okay? Okay. So I may have to, it'll be okay. We're going to do an example here. It's called chocolate chips. One of my favorite labs to run with you guys if we were still in school. But if you want to run it, you can run it. Make yourself some cookies or something like that. So Ashton and Olivia wanted to know if generic chocolate chip cookies have as many chocolate chips as name brand cookies on average. To investigate, they randomly select 10 bags of Chip Ahoy cookies and 10 bags of Great Value cookies and randomly select one cookie from each bag. Then they carefully broke apart each cookie and counted the number of chocolate chips in each cookie. Here are their results. I'll just scoop this up right now. Let's do this so you can see it. Chip Ahoy, 17, 19, 21, 16, 17, 18, 20, 21, 17, and 18. Great Value, 22, 20, 14, 17, 21, 22, 15, 19, 26, and 18. We're going to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chip Ahoy and Great Value. And then, does your interval provide convincing evidence that there is a difference in the mean number of chocolate chips? Okay, so we got all that out of the way. We are going to move into our solution set. Okay, so to find the solution, one was an independent. Well, one cookie won't affect the other. It may affect your waistline, but it won't affect the other cookie. Number 2, random. And my personal favorite, it was stated, and you don't have to put this down, but it was stated multiple times. Okay, then we have our 10% condition. And our 10% condition 10 cookies is less than or equal to 10% of all Chip Ahoy or Chips Ahoy. And then you can also do 10 is less than or equal to 10% of the Great Value cookies. Okay? All right. 4. This is our large counts. Okay? So, was it stated that it's approximately normal? Not stated. Okay? Is n greater than or equal to 30? Nope, it's not. We only have 10. So that means we need to use our calculators. Yay! Okay, so we're going to go put a list in. Don't look at that. I've already put my list in. 17. So there's all the values. Okay. So what I'm going to do next is I'm going to go to my stat plot, and I'm going to turn plot 1 on, which it is. I'm going to move over to my box plot there. I'm going to put list 1 there. Okay. Now here's the thing I'm going to do that we haven't done in a while. I'm going to hit second stat plot again, and I'm going to go to the second one, make sure that it's on there, and I'm going to put that box plot on, put my list 2. So the first list 1 is Chips Ahoy, list 2 is Great Value. Okay. So then I'm going to graph it, and I get a vertical aligned Chips Ahoy and Great Value box plot. Okay. So put that one more time. The graph shows no outliers or skewedness. Okay, so now we're going to proceed to a 2-sample t-interval. And I said it was at 99%. Wow, that's great. Okay, so now going back to my calculator, we have the data put in there, correct? We do. So what I'm going to go to is I'm going to go to 2-variable sample test. Okay, so stat, move over. So there's that list. Instead of 1 var or 1 variables, I'm going to go to 2. List 1 has Chips Ahoy. List 2 has my Great Value. And then voila! I get my data. I get that x1 is equal to 18.4. My S of x1 is equal to 1.776. Okay? Now, on the graph or on the calculator, it says that it's y. But I'm just going to, so just to keep me, well, what we're going to do is we're going to call it x2. And we know that this one is 19.4. S of x2 is 3.596. Okay? So again, 2-var sample test gives me all my data. All right? Okay, so now my t-score, my t-critical, okay, I'm at 99%. That means that I have 0.01 left over, right? I do. So I need to divide that by 2, and I get 0.5. So I'm going to pause it there. Okay, so like I said, I'm going to use my chart to make it easier for myself. All right, so 0.005 is right here because I had to divide it in the 0.01. Come down to 9, which is my degrees of freedom. So I'm being conservative, so it's 3.250. Okay? So this is equal to 3.250. All right. So to set this up, I'm going to take the mean of x1 minus the mean of x2 plus or minus my critical score. And then I'm going to take the standard deviation of x1. I'm going to take the standard deviation of x2. I'm going to square both of those, divide it by 10, and then I'm going to take the square root. Okay? So if you do this correctly in your calculator, you should get negative 5.121 to 3.121. So then we would sit there and say, we are 99% confident that the interval of negative 5.121 and 3.121 captures the true mean difference of the number of chocolate chips in Chips Ahoy and Great Value on average. Okay, so then we go to B. Is this significant? Well, because the interval contains 0, there is not convincing evidence that there is a difference in the mean number of chocolate chips and Chips Ahoy and Great Value. All right, now that takes care of that. We've done these before. We can do this on the calculator by choosing a 2-sample interval or t-interval because we have the data entered. We would choose the button data. So the 2-sample t-interval, stat test 2-sample t-interval. Hit enter. Make sure your data is there. Change your confidence interval. Pooled is no. We'll get to that in a minute. We'll probably next video. And then we'll calculate. And then this is our interval for data. And you can see that the degrees of freedom is different because they used that technology formula that we saw. And so this one would be more accurate, but the stuff we did longhand is just as fine, is just as good quality. But you would have to sit there and tell the reader that you used your calculator so they would know, they could understand that you used the technology to help get you a little bit better answer. Okay. Just keep going, guys. You're doing great. Love hearing your emails. Anything else comes up, make sure that you are talking to me, because a lot of you are, some of you aren't. Looking really good. Proud of you guys. Keep going.